In this video, let's learn how to get started using AWS CDK and understand some of the core concepts when using them. We will learn how to deploy a AWS Lambda function using a DynamoDB table using CDK. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud and DevOps. This video is sponsored by AWS and is part of my AWS CDK series. The AWS Cloud Development Kit, or AWS CDK, is an open-source software development framework for defining cloud infrastructure in code, and you can provision it through AWS CloudFormation. The CDK primarily consists of two parts: the construct library and the command line interface. The construct library is a collection of pre-written, reusable pieces of code called constructs that you can use, modify, and integrate to develop your infrastructure. The command line tool is for interacting with CDK apps and to manage the deployment of your CDK projects. The CLI is also referred to as the CDK toolkit. Now, one of the advantages with CDK is that you can author this in multiple different languages, including TypeScript, JavaScript, Java, C#, .NET, etc. In this video, I will be showing using the .NET language. When using CDK, there are three main concepts that you need to understand. Those are constructs, stacks, and app. A construct is nothing but the AWS resource and the resource that you're trying to deploy for your application. Now, for your application might consist of multiple constructs like Amazon SQS, AWS Lambda, Amazon DynamoDB, etc. Now, these can be grouped together in different forms. The stack is the grouping of these different concepts. An app sits on the higher level and consists of multiple stacks if your application requires that. Constructs are the basic building blocks of the CDK applications. Now, a construct is a component within your application that represents one or more AWS CloudFormation resource. An AWS stack is the smallest single unit of deployment. It represents the collection of AWS resources that you define using CDK construct. An app is a collection of one or more CDK stacks, and stacks are a collection of one or more constructs. So the overall grouping of your stacks and the constructs are known as your CDK app. With the high-level understanding of what a construct, a stack, and an app is, let's see this in action by trying to deploy a Lambda function using a DynamoDB table. We will do this using CDK from .NET Core. Now, before we start creating the project, we need to make sure that we have the AWS CLI installed and set up on our development machine. For this, you can use npm to install CDK, and you can find the relevant information in the Getting Started with AWS SDK documentation. I'll put a link to this in the descriptions of the video. So you can run npm install -g if you want to run it globally and install AWS CDK CLI. Once installed, you can run CDK -- version to ensure that the installation was successful. I already have the CLI installed, so if I am to run CDK -- version, you can see that it returns the version number of the CDK CLI that's installed on my machine. So let's create a new project using the CDK CLI. Now, this is done using the CDK init command, and you can specify the language to use. In this case, I'm using C#. So let me specify that. Now, this is going to create a new project inside the current folder. Now, if I list the files, you can see that there are couple of files that's created by the CDK init statement. Now, the one that is of importance is the cdk.json file, which is a configuration file for AWS CDK. This file provides the instruction to the AWS CDK CLI regarding how to run your app. You also have the git files, the git ignore, and the readme files. Now, in specific to C#, you can see that this is how the project structure is laid out. So we have the cdk.json at the root of the folder, and you have a source folder where you will have the CDK project and the solution folder automatically created for you. Now, if I navigate into the folder we just created, you can see we have the cdk.json, the source folder, and also the hello CDK project and the SLN file. So if I open this in JetBrains Rider, we can see the CDK code that is automatically generated using the CLI. The hello CDK project consists of three files, and let's navigate to the program.cs. Here, you can see that this is creating a new app and it is creating a new stack, which is passing in the app instance to that. Now, the stack by itself is in a different file, so you can navigate to the hello CDK stack to see the stack details. Now, this inherits from the class stack, and it creates a constructor, and this is where you will be defining your AWS resources for that specific stack. Now, if you navigate further into the stack class, you can see that it is also an instance of a construct class. So the construct is the basic building block in CDK. So you can see the stack inherits from construct, and the stack in itself is a construct type. The same is applicable to the app. So if I navigate into program.cs and navigate into the app, you can see that is also coming from a stage which further inherits from a construct. This is why construct is the building block inside CDK. Now, to start defining our AWS application, let me first go and add a new AWS Lambda project into this solution file. So let's right click on the solution file, let's specify add and create a new project. In this case, I'm going to create a AWS Lambda function. So let's simply create a Lambda empty function, choose C#, and let's specify hello CDK Lambda. And let's click create. Now this has created a new Lambda function for us. So if I navigate to function.cs, you can see this is a simple empty Lambda function which simply takes in a string input and returns the two upper on that. So let's first try and deploy this Lambda function before adding DynamoDB to it. So let's navigate back to our CDK class to the program.cs, and let's navigate into the Hello CDK stack to start adding our AWS resources. Now inside here, we first need to create a Lambda, so I can specify where Lambda and create our Lambda instance. To create a Lambda function, I can use the new function construct which is coming from the Amazon CDK.AWS Lambda. So let's use that class and specify our Lambda function. Now this takes in a construct scope, and in this case, we have the scope already coming in from the CDK stack constructor. So let's pass that in to the scope. Let's specify an ID for this. So let's specify hello CDK Lambda. And this also takes a function properties. So let's create new function props and pass in some properties to this. Now in this case, we need to specify the runtime, which is going to be .NET 8 in my case. So let me use the appropriate runtime. So let's specify .NET 8. Let's also specify the handler function name. So you can get the handler function name from the AWS Lambda function details. So if I navigate into the project and go into the AWS Lambda tools, you can get the function handler from here. So let's copy and paste this inside the handler part. Let's also specify the code that is going to be deployed. Let's pass in the path where this code will be found. Now, in this case, when I package this application, it is going to be bundled up inside the same root folder in source. So if I was to build this Lambda package, we can see where the package is going to exist and copy that path and put it in here. So let's navigate into my command line. Let's open a new console tab and let's navigate to this folder path where we have the function created. And let's navigate into the source folder and to the Lambda function folder. Now in this case, let's package this Lambda function first. So let's create the .NET Lambda package command, which is going to package this Lambda function. Now ideally, this would happen in your build deploy pipeline where you would have your build commands to package the application. Now it looks like I'm in the wrong folder. So let's navigate further into the source folder before we run the package command. So we have the Hello CDK Lambda inside here, and we have the CDK project right over here. So let's run again the .NET Lambda package command, which is going to package this project. So you can see that this is going to package this and put this as a zip file inside this root folder. So you can see the path inside here, and we can use this path to specify in our code deployment. Now this will vary based on how and where you're packaging your application. So let's copy the path till the source folder and let's use that inside our code. So let's copy this and let's come back to our Hello CDK and paste this inside here. So we have the copied path inside this. Now the code property accepts a type of type code. So let's use the class code to create this type. Now in this case, this is coming from asset. So let's use code.fromAsset and pass in this path to that. So we have the code class created by passing in this folder. This is where we can find the package zipped up folder for the Lambda function deployment. Now if you want to clean up the string, you can do that as well. So let's use Rider to help us, and let's clean up that string so that it has only one slash in that. Now, once we've specified this, we are good to deploy this specific CDK because we've created our Lambda function, we've specified the handler and also the path for the package to be retrieved from. So let's see how we can deploy this CDK. So let's make sure that this builds. Let's navigate back to our command line. Now, before we use CDK toolkit on our AWS account, we need to make sure that we run CDK bootstrap. Now, this is the command that helps us to bootstrap our AWS account with CDK requirements. The bootstrap command prepares your environment for CDK deployments. So as soon as you run bootstrap, it is going to create some resources inside your AWS account. So you can see it under the CloudFormation stacks. There will be a new stack name called CDK Toolkit, which will have all the resources that the bootstrap creates. So these are basically IAM roles, the ECR repositories, S3 buckets where it is going to upload the code, etc. You can look through the resources once you run AWS CLI Bootstrap and make sure that it is set up successfully. Now, since I've already run Bootstrap on my account, I don't have to run this again. However, if you were running this for the first time, you would be calling the CDK bootstrap command from your account and making sure that this is getting set up. So once you have the bootstrap command set up, we can use the CDK deploy command. Now, making sure that I'm in the root of the path where I have the cdk.json file, I can run the CDK deploy command. Now, this is going to go through our code, the CDK code that we have authored, and see what the stacks that needs to be deployed. So now this throws an error which says function at CDK Lambda should be created in the scope of a stack, but no stack is found. So if I come back to our code, you can see that I have passed in the scope to the function. However, this scope is the scope that's coming into our CDK stack constructor, and that is being passed as the app. So we're not directly adding it to the stack, however to the app, which is why that error was thrown. So in this case, to fix this, I'll have to actually pass this instance, which is the current stack instance, to my function so that the function will live inside this stack and the stack will live inside the app scope. So once we fix that, let's navigate back to the CLI and let's try to deploy this again. So let's run CDK deploy, and this time it should succeed. Now you can see here that these are the changes that this CDK deployment is going to affect. So you can see this is going to create a new IAM role and also a new resource, which is our Lambda function. So once we look through this and make sure that this is good, we can type in yes, which is going to deploy these changes. So it asks for confirmation before making any changes to your account. On a build deploy pipeline, you would have this automated so that you don't have to manually enter the confirmation. So now this has started creating the CloudFormation, and if you navigate into your AWS account and if you refresh on the CloudFormation, you can see the stack that is getting created. So you can see the hello CDK stack and the create is in progress. If I navigate into that, you can see the resource that it's getting created. So here we have the Lambda function, which is being deployed right now. So once this is completed, we'll get back a notification on our CLI that the deployment is complete, and it looks like it is all done right now. So if I navigate back and refresh this, you should be able to see the Lambda function. So now we can see the hello CDK Lambda and navigate to this Lambda function. Now here we have the symbol Lambda function that's getting deployed. Let's test this. So let's navigate into the test and let's pass in a string. So let's specify hello CDK and send this string to this Lambda function. Now this should return back in uppercase, which is what our Lambda function does right now. Now this Lambda function has an auto-generated name by itself, which we can specify when using CDK. So if I go to our code, you can specify a name for this function. So let's specify the name and let's specify this as hello CDK Lambda. So once I change this, I can navigate back to the CLI and run CDK deploy again. And this is going to push the new changes to the Lambda function. In this case, this is going to change the Lambda function name. So let's wait for the CloudFormation change set to be created and to update this specific change. The update is done. So let's switch back to our AWS account. Let's refresh this. And here in the AWS Lambda, you can see that the name is now hello CDK Lambda. So if I navigate into that, the name is also reflecting inside our functions. Now let's see how we can add a new AWS resource to this. So let's assume we have a DynamoDB table and we want to store data inside the DynamoDB table. So let's navigate back to our code. Let's add the DynamoDB NuGet package so that I can use it from my Lambda function. So let's search for DynamoDB in this case. Let's search for v2 and let's add this to our Lambda project. So once we have the DynamoDB NuGet package, we can start using it inside our code. Now all I'm going to do is simply write this input into a DynamoDB table. So let's assume we have a class that's called user and let's create a username. So in this case, let's specify the username and let's create the new context inside here for new DynamoDB context. and let's use that to write the data. So let's create a DynamoDB context. And let's also pass the Amazon DynamoDB client, which is how you would create the instance. And let's create a new user in here. And let's also pass the username to it. So let's make this as the input, which is going to be the username. So let's make sure to await this because the save async is an asynchronous method. And let's also make the Lambda function an async method. Now, since context already exists, let's rename this to be DynamoDB context so that it doesn't conflict. And let's call the save async on the DynamoDB context. Now, in this case, I don't have to return anything, so let's remove this return statement. So let's simply make this as a task. Now our function creates a new user and writes this to the DynamoDB context. Now what's important for us here is that for the application, we need a new DynamoDB table, which is going to be the user DynamoDB table. So let's go and create one using Amazon CDK. So let's navigate back into our stack in our Hello CDK stack and let's create a new DynamoDB table. So let's specify this as user table. Now in this case, we'll create a new table construct, which is basically coming from Amazon CDK.aws.dynamodb. So let's create a new table construct. And let's do the same by passing in this, which is the stack reference. Let's pass the user table reference. So that's going to be user-table. And let's also pass the table props in this case, because this is the table properties that it requires. So let's create a new instance of that and let's pass in the information. Now, in this case, we can specify the table name if we need. So let's make this as the user. Now for DynamoDB, we need to specify the partition key. So let's specify that first. So let's create a new attribute as the partition key and let's pass the name for that. So this is going to be an ID and that the type is going to be the attribute type of string. So we'll need to make sure that we have an ID property inside our class. So let's switch back to our function.cs and let's create a new property IDs, which is going to be of type string, and let's create a new ID. We can also set this inside our class. So let's create a new ID and let's simply create a GUID.newGUID and convert that to a string. So we have an ID and a username inside this right now. So let's navigate back and let's continue adding our user table. Now, once we have the user table, this is going to create the table inside DynamoDB. However, we need to ensure that the Lambda function has the appropriate permissions to talk to this user table. Now, to do that, we can call functions on the user table object. So we can specify different grant functions on that specific object. Now, in this case, let's simply specify grant read write data. So this will have read and write access to this specific user table. Now, we need to pass the Lambda function in this case that we have created. So let's pass in the Lambda instance, and this is going to grant the read write permission. Now, by default, when the CDK creates stateful resources like the DynamoDB table, it sets the removal policy on these objects to be retained so that it doesn't get automatically deleted. So we can change that by specifying the removal policy, and you can specify if you want to destroy it or retain or the other options that this provides. So in this case, let's specify destroy so that it gets destroyed in case we decide to destroy the entire application stack. So let's keep it as destroyed. However, in a real-world application, depending on your use case, you might choose to keep the removal policy as retained so that you can still use the data that's stored inside your DynamoDB table even after the functions are deleted independently. Now, once we have these changes, let's navigate back to our command line and let's run the CDK deploy again. So we have created a new DynamoDB table and also granted access for the function to talk to this DynamoDB table. Now, since there are new resources that's getting created, it's prompting the changes that it's going to make. So you can see that the IAM state changes. So let's specify yes. And this is going to create those resources. So if I navigate back into my AWS account and refresh this, you can see this is now in update in progress. So new resources will be added inside here. So you can see there is a user table being created, and that is the Amazon DynamoDB table. So if I navigate into that, we should be able to see the DynamoDB table that is getting created. So right now it is in the creation mode. So once this is done, we should be able to start using our Lambda function. The deploy is successful, so let's switch back and let's refresh this, and this is now all completed. So let's navigate back to our Lambda function and let's go to the test tab and let's create a new test. So in this case, let's specify hello CDK again and let's test this. So let's click the test button. Now this is going to connect to our DynamoDB instance and store that data in DynamoDB. So if I navigate to the DynamoDB and go to the explore table items and refresh this, the items are not yet there. This is because when we deployed, we did not package our Lambda function again. So you can see that our Lambda function is still returning the hello CDK in caps. So let's navigate back and let's make sure we package our Lambda function. So let's switch over to the Lambda function directory and let's run the dotnet lambda package command. So this is going to create a new package which has the changes that we made to talk to DynamoDB. So once the package is created, let's make sure to run the deploy again so that it deploys the updated package. Now once we set this up inside build deploy pipeline, the packaging will automatically happen. So the deploy is complete of the latest package. So if I run this test again, so let's click test again in this case. Now in this case, it's going to finally use the new code. Now you can see that this has timed out and it has timed out after 3 seconds. So this Lambda function tried to execute it in 3 seconds. However, it was not able to establish the connection to DynamoDB because also of the cold start times with the Lambda function. So if I navigate into the configuration, you can see that the timeout is right now 3 seconds. This is why this did not successfully complete. So let's switch back to our AWS CDK and let's change the timeout on this Lambda function. So we can specify a timeout property. So let's specify the timeout property and let's simply specify this in duration in seconds and let's specify this as 30 seconds. So once we have made that change, since the package is the same, we don't have to rerun the package command, but let's run the CDK deploy. Now this is going to change the timeout of our Lambda function so that it gets more time to execute. The update is complete, so if I switch back and refresh this page, you should be able to see that this timeout is now 30 seconds. So if I come back to our test tab and let's pass in the information again, so let's pass hello CDK and let's click the test button. Now this time we have enough time to establish the connection to the DynamoDB and then write the data into the database. Now this takes this much time on the first run because of Lambda cold start and also that it has to establish a connection with DynamoDB. Now on subsequent calls, this should be much faster. So let's specify Rahul as the name and let's click test, and this time it returned back much faster because the Lambda instance is already created and it is getting reused. So if I navigate into the items and refresh this now, you can see there are 2 items in our DynamoDB table. So we have the hello CDK and also Rahul username in here. So if I navigate back, you can add more items to this. So let's specify hello, and that should reflect inside our DynamoDB table. Now this is much quicker than the first run because of cold start and also because of establishing a new connection with DynamoDB. So if I navigate into the configuration of this Lambda function, you can see the permissions. So you can see this has the DynamoDB permissions, which was given by the read-write permission that we granted on the CDK code. So all we had to write was one line of code to specify grant read-write data and specify the Lambda function, and this set up all the required permissions for that Lambda function to talk to that DynamoDB table. So we were successfully able to set up a Lambda function and also a DynamoDB table and deploy that to the AWS account. Now, if you want to delete this resource stack, you can simply come in here and specify CDK destroy, and that's going to delete that specific stack inside our application. So this is prompting whether you're sure to delete the hello CDK stack. So you can specify yes, and this is going to delete both these resources. Now, since I specified the DynamoDB to be deleted as a retain policy, it is also going to delete the DynamoDB table. If not, it would have retained that specific resource. So if I navigate back to the CloudFormation and refresh this hello CDK stack is currently being deleted. The delete is complete and the stack is completely removed from our AWS account. So if I navigate back, you can see this step is also completed. If you want to learn how to set up AWS CDK on a build deploy pipeline, let me know in the comments below and I'll do a separate video on that. I hope you liked this video and was able to get started using CDK for your applications. Hit the like and subscribe button to help me grow this YouTube channel. Thank you and see you soon in the next video.